Good morning, students. Today I demonstrate another electrical experiment number 2. The experiment is based on to determine the resistance of about 50 centimeter constant and wire of a coil resistor by Wheatstone bridge principle using a meter bridge. The apparatus required here, you see a meter bridge, 100 centimeter wire fitted on a wooden frame, a central zero galvanometer, a plug key and a resistance box 0 to 10 ohm, a coil resistor whose resistance is to be measured, a DC source 2 volt, a pencil jockey. What is the theory? Already you know the Wheatstone bridge principle. So according to Wheatstone bridge principle, we shall find out the value of the unknown resistance R of the coil resistor through the formula R equals to capital R 100 minus L by small l. When the bridge is balanced, then we find the null point. What is the null point? At the null point there is no deflection in the galvanometer. So we take the reading of the small l, and this is the part, calculated part, 100 minus L. And also we will find the value of the R by taking a graph against R. What is the R? The resistance leaped from the resistance box, and this parameter, this is calculated portion, y equals to L by 100 minus L. And from this slope and using this formula, we can find out also the value of the R. Now I perform this experiment. Now I on the plug key. You see, when I on this key, there is a deflection on the galvanometer on the right side. Also, there is a deflection in the left side. So the connection should be ready. There is the perfect connection. Now I lift 1 ohm resistance from the resistance box. To take the null point, we just touch the jockey here. You see there is a deflection of the galvanometer. Then I touch the jockey here. Also there is a left side galvanometer. So there the null point within this zone. Now I touch the jockey here. So there is some deflection. I touch the jockey as 29 centimeter. There is some deflection. In 33 there is some deflection slide. So in 36, say in 36 there is no deflection. So the null point should be arises. In such manner, I will take the another null point against 2 ohm. This is 51.8 centimeter, 3 ohm 60.9, in 4 ohm 67.1, and 5 ohm 71.5 centimeter. And then you calculated this value 100 minus L, and from this data you can find out the unknown resistance small r. This is 1.7, 1.8, 1.92, 1.96 and 1.99 ohm. And finally you take the mean of this 5 data. So the ultimately value of the small r is 1.87 ohm. Now I calculate this value of r from the graph. You see, this is the graph. Here I plot the value of R. The resistance should be lifted from the resistance box in the x-axis, and this calculated parameter y equal to L by 100 minus L in the y-axis. So in this table you see, in 1 ohm the calculated parameter is YL 0.56. So here you see, it is very important, you choose the smallest division. I choose the smallest division along the x-axis is 0.1 unit, one smallest division. In case of a y-axis, I also choose the one smallest division is 0.05 unit. So you see in case of a 1 ohm, this value is 0.56 here. So in such a manner, I plot the another 4 data, and it will take a straight line graph passing through the origin. The line of best fit should be drawn. That is, the maximum data will cover through this straight line, and from this straight line I choose 2 unknown points, and from this I draw the gradient. This is the gradient, this is the angle theta. So delta S equals to change in y by change in x, that is 2.25 here the value of y2, and y1 is 0.5. Also x2 is 4.4 and x1 is 1. So after calculation you will get delta S equals to 0.51, and then using this formula r equals to 1 by delta S, and then putting this value you get the r is 1.96 ohm, which is more or less equal to the manually calculated 1.87 ohm. These two data are corrected. Some precaution you should here. First, remove the insulation from the ends of the connecting wires completely before making the connection. The connection should be tight. All the plugs of the resistance box should be tight. Remove the plug from the key while making the connection. All the reading must be taken within such value of R, that is the balance point remains nearly in the center of the galvanometer. This is your complete practical. You will write down in your lab copy to draw this diagram in the white portion. Now I move another second practical.